Welcome everybody to another one of James's videos. Today we're going to be working with another type of solving 2D triangles using your sine rule, area rule, and cos rule. Okay, so this question, 10.1, this is your more difficult types of questions where they ask you rather to prove something because our sides are all in terms of variables and our angles are all in terms of variables. So we don't have actual lengths and actual angles we're dealing with. So it does prove to be a little bit more difficult, but at the end of the day, if you are strong with your algebra and fraction work, it shouldn't be a problem. Okay, so let's have a look at this question. Use the diagram and prove that DC equals P sine X cos Y all over sine of X plus Y. Okay, so where do we start here? The first thing we do, and remember I mentioned this in the previous videos, you first identify your triangles that you have, that you're dealing with. So the one triangle that you have to identify is the triangle with the most information. So for me, it's this triangle here. The triangle that's going to have our final piece of information in it is this triangle here. Also remembering that the blue triangle is a non-right angled triangle, which means your rules are in play. And then the yellow triangle is a right angled triangle, which means your SOHCAHTOA is what's going to help you in order to make your equation. Okay, so the first thing that I do as well when I approach these questions is I fill in as much as I possibly can without even starting the question. So some angles in a triangle, complementary angles, supplementary, all that type of thing, fuzzy X, all these things in geometry that we were taught in the younger grades, they all come into play now. So do you agree with me that angle D would be 180 minus X plus Y, some angles in a triangle? If B's angle is 90 and ABD's angle is Y, then this would be 90 minus Y, okay? And then this would also be Y if you had to complete all the angles. Okay, so everything that I can put into this drawing, I have now put into it using all these things. So what's the lovely about this section is actually you don't have to state your reasons. Like I said in the previous videos, sometimes it's good to just cover all your avenues. But in this case, we're just going to leave it and we're just going to state there. Or maybe I should put it in. Let's put it in. Why not? Okay, so the first thing that I worked out was for 10.1, I worked out that ADB is equal to 180 minus X plus Y. And the reason for that is because some angles in triangles. Okay, just for explanation purposes and teaching purposes. And you always have to check with your teacher, guys. At the end of the day, they're marking your paper. So maybe go up to your teacher and ask them, ma'am or sir, please, do we have to put reasons for using and solving for 2D triangles with our trig? Yes or no? And then you'll know whether to do it or not. Okay, but I'm going to be doing it just for teaching purposes and explanation purposes. Cool. The other thing we did was we worked out that DBC was equal to 90 minus Y. And that's just complementary angles. So complementary angles. And then angle BDC, although I don't think we're going to be needing this one, is Y, and that's just some angles in triangle. Okay, cool. So everything that I have put in the drawing, I'm at least covered for, and I can sleep well tonight. You know what I mean? Okay, cool. So next thing we're going to do is the two triangles that I have, the common side of those two triangles is BD, guys. So that is the side that I'm going to use the blue triangle to get. So I'm going to use the triangle that has the most information, which is my blue triangle in this case. And I'm going to use that to work out BD. What that's going to do is that's going to put more information into my yellow triangle, which I'm now then going to use to work out my final side and final answer. So let's go ahead and use that blue triangle. The rule that let's look at the scenario as well. The rule that I'm going to be using is I'm going to be using sine rule because I have a side and I have the angle opposite that side. And I also want to work out a side and I've got the angle opposite the side that I want to work out. So we start off always with our unknown. So BD over sine of X is the opposite angle to BD, equals P over sine, and I've got 180 minus X plus Y. Okay, and that is my sine rule. Now I want to solve for BD. So BD, I'm going to bring the sine X up. Okay, so that's always what we do, guys. Remember, we're going to bring it up there, and that's going to be timesing. So it's P, wrong color, P sine of X all over. Now, guys, this is very important. 180 minus something is a reduction, isn't it? Don't you remember from when we were doing reductions that sine of 180 minus theta, what does that reduce to? Doesn't it reduce to positive sine theta? Yes. Why? Because 180 minus is the sine quadrant. Okay. So sine is reduced to positive there. So that's exactly what we're going to do here now. We're going to reduce this into positive sine of x plus y. X plus y is my acute angle. Okay. So now I've got BD, which is fantastic. Now what I'm going to do is I'm going to use BD in my yellow triangle to solve for DC. So remember, I've got this side, I want this side, and I've got this angle. So we can use opposites, or we can use the 90 minus y angle, and we can say opposite over hypotenuse, opposite, hypotenuse. What trig function uses opposite and hypotenuse? Sine. So sine of 90 minus y equals opposite, which is DC, over, let's move across a little bit, my BD, right? So I'm just going to put BD here, and we're going to do it in our next step. So sine of 90 minus y equals DC over, what is BD? We worked it out in our previous calculation. So P sine x all over sine of x plus y. Fantastic. Now, do you agree with me that sine of 90 minus y is actually cos y? Why? Because that's a co-ratio, isn't it? Co-ratio. You see how all this stuff makes and comes into play, everybody? So we need to remember this stuff, okay? So cos y equals, now what I'm going to do you agree with me that this is the same as me saying DC divided by your P sine x over sine of x plus y? All I've done is I've changed this fraction line here into a divide. Now, how do you get rid of something that's dividing? You times it, right? So I'm going to times by both sides by this fraction, this one over here. I'm going to times both sides to get it across, to get the DC by itself. So that's going to be cos y P sine of x all over sine of x plus y equals DC. Now let's put it into a format that they wanted. So what did they want it? They wanted the P and then the sine first. So you can switch it around. So P sine of x cos of y all over sine of x plus y equals DC. And there you've proven it. Okay, does everyone understand? That's fantastic. So again, not really difficult. We're not changing our methods here. The only difference now is that you need to be strong with your fractions. You need to be strong with your trig identities, your trig reductions, as well as your SOHCAHTOA. Okay, and your co-ratios. You need to remember those. Okay, so 10.2 is actually it's a very common style or setup that these questions take. Is they'll ask you to prove something, and then the last question would literally be calculate the actual value if this equals this equals this. So it's just a substitution question. So if we know that DC is equal to what we proved it to be, they said P was 50. So 50 sine of 80 cos of 70 all over our sine of 80 plus 70. Okay, so now that we have that, we can put that, and it's literally just calculator work, guys. But then again, a lot of people get despondent in an exam, right? They think they can't get the proof, and then they just leave the question out. But you guys need to watch out, because sometimes they give you the answer, or you have the proof, and then the second question is just a matter of substitution. So you might have skipped that whole question thinking you couldn't have done it, and there you lost your marks by literally just doing a bit of calculator work. Okay. So never ever give up on the question. Read all the questions, because sometimes you don't need the question before in order to carry on with the question. Okay, and that is going to be meters. Okay, everybody happy? So that was quite a hectic level question. So let's absorb it. And if you like the video, guys, please click the subscribe button below. We'd love to have you join a few more of them. And then also all these notes are available in the James book, which is for sale. So if you are keen for a copy, please let me know. Awesome. Look forward to seeing you guys at the next video. Have a great one.